Okay, today we're going to talk about measures of central tendency. Do you remember in lecture 9 we talked about the median and the quartiles and the interquartile range, right? I want you to remember median. Do you remember what that is? The median is where you list your data points from smallest to largest, and then you pick out the center, right? That's what the median is. I don't think we need to repeat that here because there's a whole lecture on that. If you want to go rewatch lecture 9, you can see that. But the important thing is I just want you to remember how you find the median, and I want to point out to you that the median is one way of determining the center of your data set. Okay, and just write this here. Recall that the median is one way of determining now I'm going to put the word center in quotation marks. The center of your data set. Why I put some center in quotation marks? Because there's other ways of determining the center based upon other ideas of what it means to be the center. Okay, the median is the center when you list the data points from smallest to largest. But there's other ways of defining the center as well, and some of them have pros and cons. Well, I should say they all have pros and cons, but the pros of some ways of defining the center might be some cons for other ways, and vice versa. Okay? So another way of determining the center, and this is a super easy one. So let's write it this way. A different way of defining the center and this is one that's not used super commonly, but it does occasionally have its place. And that is by finding the most common data point. And that's called the mode. Okay, so we have median, which is where you list the data points in order from smallest to largest, and then you pick the center, okay, of that list. Mode is where you look at the data points. They don't need to be listed in order, but you just figure out which one is the most common. Okay, and that's another way of defining center. It's a very different kind of center. It's a different definition for center because it might not really be in what you would consider the geographical location of the center. Like, what would be an example of where you would want to use the mode? Let's suppose you lived in a dorm of, let's say, 100 people, okay? And your dorm was going to have a party, and you were going to buy some pies to eat. And so you voted on how many pies you should buy. Some people say, oh, we just need to buy one. And some people say, oh, we should buy two. And Other people say, well, there's 100 of us, we should buy 5 pies and whatnot, right? So how would you choose the winner of that? Is you would go with whichever number got the most votes, right? So that would be the mode, okay? And that's not what you normally think of as the center, but in statistics, that is considered one way of defining the center. Not really the center location, but just the most common answer. Okay? It doesn't get used very often in my understanding, but it is there, and sometimes that's the type of center that you're looking for. Okay? If it's just a common vote, you want to know which choice had the most votes. That would be your mode. Okay? And then there's one more that you are actually very familiar with ever since you're a child, and that is the simple, old-fashioned average, which, of course, average only works if the data is numerical. Okay? So, a third, and we'll put this in parentheses here, and very common. I would even say that this is probably the most common way of defining the center of a data set. Is by calculating the average. Okay? And the average is called the mean. Technically, what we're going to do here is called the arithmetic mean. And the only reason it has that extra word is because there's another kind of mean as well called the geometric mean. We're not going to do that right now. If we need the geometric mean later, then I'll introduce it to you and show you what it is. Okay, but I don't want to do that unless we actually need it later. So I'm just going to show you this one, which is called the arithmetic mean. Now, you will almost never hear the word arithmetic. People usually leave it off. They just say the mean. But I've told you that there's two kinds of mean, arithmetic and geometric. So if you see the word mean, how do you know which one it is? Well, the answer is this. If someone just says mean, they mean the arithmetic mean. Okay? If it doesn't say arithmetic or geometric, then it's arithmetic. And that's the one I'm going to show you. So there shouldn't be any confusion because I'm only going to show you this one. Okay? Unless we end up needing the other one later. All right. So here's what we're going to do. I'm going to practice with you calculating these three things for a data set. And I want to show you a few things that will give you an idea of when you might want to use one versus the other. Okay? I'm going to show a picture of a data set. Okay, look at that graph right there. Here's a little quiz. What kind of graph is that? What's that picture called? So it's got bars, right? So it's either a bar graph or a histogram. Which of the two is it? Well, the bars are touching each other, which means that it's a histogram, right? Okay, so let's write down the frequency of each of these data points. How many people, when you asked them a survey, how many people recorded an answer of 4? There's one of those, right? I'm getting that from right here. Let me label these for you. So there's one data point of 4, there's one 5, there's 2 6s, there's 6 7s. Oh, I'm sorry, I miscounted. There's not 2 6s, there's 3 6s. There's 6 7s, there's 3 8s, and then there's 1 9 and 1 10. Okay? Let's make a frequency table of that. Okay, 4 has a frequency of 1, 5 has a frequency of 1, 6 has a frequency of 3, 7 has a frequency of 6, 8 has a frequency of 3, 9 has a frequency of 1, and 10 has a frequency of 1. So there's a frequency table. I'm trying to remind you of the things we've learned so far by doing them again with you. Okay, now here's what I would like to do. Let's find the mean, median, and mode, but not in that order. Let's do them in the order that I wrote them down up there. Let's do median, then mode, then mean. Okay, just to make sure you know how to find all three. So, median. Let's find that. So we list them in order. So there's a 4 and a 5 and 3 6s and 6 7s. Do I really need to write the list out? No, I don't, right? But I'm just doing it anyways. But I could get the information off of that frequency table. There's 3 8s and a 9 and a 10. So how many data points are there? I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 of them. So where would be the middle? Right between number 8 and 9, right? Right here. Which means the number that's halfway between these two. Well, what's halfway between 7 and 7? The answer is 7. So that's our median. Okay. Now I didn't really need to make that list, did I? Because I could have just done this. I could have just added these up. Hang on a second. Let's rewind a little bit. There was 16 numbers. I'm not sure I put that green arrow in the right spot. I know the median is 7, but I'm not sure it's located in the picture correctly. There were 16 numbers, and so I said the middle of that would be right between, did I say the 7th and the 8th one? Because it should be right between the 8th and the 9th. That's the middle. Let me count and make sure I put the arrow in the right place. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it is in the right place. All right. So after that little detour, what I was saying was you don't have to list out the numbers. It wasn't too painful for me to write out those 16 numbers, but what if it was 116? I wouldn't want to write those all out, would I? I could have just added these up and found out that there are 16 numbers, and then just counted down to the 8th one, in which case I would say there's 1, and then 2, and then 3 more makes 5. So to get to the 8th one, I would need to go 3 more numbers, which would be right in the middle of here, right? That would be another way I could find the middle. Okay, and all of this is in lecture 9. We're We're just reviewing right now, lecture 9. Okay, now let's do the two that are new. Let's do the mode. Mode is the easiest center to find. It's just the most common number. So again, look at this list. Which number is more common? 7 is. Or you could look at our frequency table and say, which one has the highest frequency? It's right there. It's the number 7. Okay, so the mode is 7. The median and the mode both happen to be 7. That's interesting. Okay, now let's practice finding the mean. So we add all those numbers in the list up. Okay, let me write that down. 4 plus 5 plus 3 6s. It's a little time consuming, but I'll show you a shortcut in a second. Plus 6 7s. Plus 3 8s. Plus a 9. Plus a 10. Okay, there we go. And then we divide that by, how many numbers are there? There's 16. Okay, so that's going to equal 112 over 16, which equals 7. And so that's our mean. Okay? So the median, the mode, and the mean are all 7. Now, as I promised, I will show you how I could have found the mean without writing all the numbers out. What I could have done is this. I could have said, well, there's 1 4, and there's 1 5, and there's 3 6s, and 6 7s, and 3 8s, and a 9 and a 10. It doesn't save a lot of time writing it this way, but it saves a little bit. Okay? All right. So the median, the mode, and the mean are all 7. And I think if you look at that picture, I think you would agree. If I said to you, what's the data point that's in the center of that picture? I think you would agree. It's 7, right? These are all 3 different ways of defining the center, and they are called, look at the name of the page here, measures of central tendency. That's what these are all called, okay? Measures of central tendency. We have the median, the mode, and the mean. And no matter which of the 3 we do here, we got 7. So that brings up a question. You might ask, well, if they're all the same, then why do we even bother with 3 different ways of doing it? And the answer is, well, that's a very, very good question. And luckily, there's a good answer. The answer is they don't always come out to be the same. Look at that picture. I'm going to use a word to describe that picture that I'm sure you're familiar with. That picture is very symmetric. You know what that word means, right? The left half looks just like the right half, like it's a mirror image. Okay? If your data set is perfectly symmetric like that, then the median, the mode, and the mean will all be the same number. But data sets are usually not symmetric. Let's look at another data set that is not symmetric. Okay, look at this one. This one is not symmetric. It's called skewed. Look at the overall shape here. Let's go back to the first picture. That one, which is nice and symmetric, if you try to just draw the basic shape, it goes basically like this. So you've probably heard this called a bell curve before, right? But look at this picture. It's not like that. This one goes more like this. And then it trails off like that. Do you see that? It's got this tail over here. So it's called skewed left because it has a tail on the left hand side. Okay. Now let's find the median, mode, and mean for this data set. Okay. Let's practice doing a frequency table. Let's write the frequencies in the picture. There's a 4 and a 5. I should label this y-axis. I don't know how come they didn't label it in the picture. Okay. By the way, I'm getting these pictures off of page 78 in the book, okay? So there's a 4 and a 5, and there's 3 6s, and there's 4 7s, and there's an 8. Okay? So 4 has a frequency of 1, 5 has a frequency of 1, 6 has a frequency of 3, 7 has a frequency of 4, and 8 has a frequency of 1. A minute ago I said there's 3 6s, and then I wrote the number 6 up there, but I just fixed it and made it into a 3. Okay, so there's a frequency table. Okay, let's find the median and the mode and the mean. Okay, so median. How many data points are there? There's 10 data points, right? Because there's a 4 and a 5 and 3 6s and 4 7s and an 8. That adds up to 10. So the median will be right between the 5th and 6th one. What's the 5th data point? Count. 1, 2, and 3 more makes 5. So the 5th data point is a 6. And the 6th data point will be a 7. And so the median is halfway between 6 and 7. Well, that is 6.5, isn't it? That's the median. Okay, let's find the mode. The mode is the most common data point. Well, that is 7. You see, the median and the mode aren't the same this time. And let's find the mean. Okay, there's a 4. And there's a 5. And there's 3 6s. And there's 4 7s. And there's an 8. For a total of 10 numbers. Okay, so let's add that up on top. That comes out to 63. And when we divide that by 10, we get 6.3. So that's the mean. See, they're all different. So let's put this in the picture. Let's draw an arrow pointing to each of those. All right, we'll move this here out of the way a little bit. There we go. Okay, so let's put a green arrow here pointing to each of those. So where's the median? The median is 6.5. So that would be halfway between 6 and 7. So here's the median. Okay, we'll do this in colors. So there's the median is green. Let's do the mode in red. The mode is 7. So that's right here. Okay, and let's do the mean in blue. The mean is 6.3, which would be right about here. Okay. What I want you to notice is this. The data is skewed left. And what does that do? It pulls the median a little bit to the left of the mode, and it pulls the mean even further to the left. Okay, let's write that down because this is important. When the data is skewed left, the median is pulled to the left of the mode, and the mean is pulled even further to the left. Okay, so you might think, okay, so then the mode is the best one, and that's not what I'm saying, because it might not be, because think about it. If the data is skewed to the left, then is the mode really a good indication of the center? Not necessarily, because the mode is way the heck over here. Like I said before, if you were voting on something, then that might be the best place to call the center, is the most common vote. Okay, but if there's a lot of stuff over here, then maybe it's better to call the center something else further that direction. So the median maybe is a better choice of center. Okay? Remember, it's the same word center, and there's just 3 different definitions. Sometimes we define the center as being the median, sometimes we define the center as being the mode, and sometimes we define the center as being the mean. It all depends upon what you're doing. And I'm not going to ask you at this point right here, which one should you use, because you don't have enough information yet. I'm just trying to show you what the differences are. I'm not teaching you yet how to make a good choice. Okay? The important thing I want you to know right now is that when the data is skewed to the left, it pulls the median to the left, and it pulls the mean even further to the left. Okay? All right, now let's look at some data that's skewed to the right. Okay, look at this data. You see how it's skewed like this? It's got that tail over on the right-hand side. So that's called skewed right. Or you could say right skewed. It's up to you. Okay, what do we have here? There's a 6, and there's 4 7s, and there's 3 8s, and a 9 and a 10. Let's fill in this frequency table. Let's find the median, the mode, and the mean. The 3 measures of central tendency. Okay? So there's 10 data points. So the median will be right between the 5th and 6th one. So let's find it. There's 1, and then 4 more is 5. So the 5th data point is a 7. And the 6th data point will be an 8. And so median is halfway between 7 and 8. So that's 7. Whoops. That's 7.5. That's the median. Okay, let's put that in our picture. 7.5 would be right about there, halfway between 7 and 8. Okay, what's the mode? The mode is the most common data point, which is a 7. So the mode is a 7. So that's right here. Okay, let's find the mean. So there's a 6 and 4 7s and 3 8s and a 9 and a 10. And that's a total of 10 numbers. So that adds up to, on the top, 77. And when we divide that by 10, we get 7.7. That's our mean. Let's put that in the picture. That would be right about here. Look, it's exactly the opposite situation of this one above us here. You see that? When the data is skewed right, let's zoom in again. The median is pulled to the right of the mode, and the mean is pulled even further to the right. Let's write that down. And the data is skewed right. The median is pulled to the right of the mode. Comma, and the mean is pulled even further to the right. Okay. Now I want to look at just those 3 pictures. Okay. So here's what I want you to take away from this. I want you to know how to calculate the median and the mode and the mean. And I also want you to know this. When the data is symmetric, then we end up with the mean, median, and mode all lining up right in the middle. Okay. When the data is skewed left, then you have the median is a little bit to the left of the mode, and the mean is even further left. And when the data is skewed right, the median is to the right of the mode, and the mean is even further to the right. So what that means is skewness moves the median in the direction of the skewness, and it moves the mean even further. Okay? So we say that the mean is more sensitive to skewness than the median. And both are more sensitive to skewness than the mode. Okay? Let's even write this down. You have the mode is least sensitive to skewness. And the mean is most sensitive to skewness. And then right in the middle you have the median, which is sensitive to skewness, but more than the mode and less than the mean. Okay? Now I want us to concentrate just on these two because the mode is important sometimes, but you will find that almost always we will use the median or the mean. I'm going to cross out mode, and I'm not saying to forget what mode means. I'm just going to cross it out because in all honesty it is the least often used. Let's just actually erase it. Almost always we will use either the median or the mean. And so what I want you to know is that the median is less, not least, but less sensitive to skewness. And the mean is more sensitive to skewness. That's important. Now, please know that. Because this gets to the question of which one should you use to indicate the center. And I'm going to give you an example. Okay, what sort of things do you think might cause skewness? You don't have to answer that. It's a rhetorical question. I'm going to tell you the answer I'm thinking about, and that is outliers. If you have some outliers on one side, it will skew the data set in that direction. Okay? If you have outliers on one side, it'll skew the data set in that direction, which means it'll pull the mean quite a ways in that direction. So, if you have outliers, then you might choose to use the median instead of the mean. Now, a classic example of that where outliers are common is in home prices. If you asked yourself, okay, I live in Stanislaus County, I'd like to buy a house and I want to know how much I should expect it's going to cost, so you can look up the data to find, all right, how much do houses cost in Stanislaus County? Okay, housing costs are notorious for outliers in the positive direction. Because, and it's like this in every town in the country, you have the majority of the houses have a price that's kind of clumped together. Some are more expensive than others, but they're mostly clumped together. And in every town, the few richest people in the town own houses that cost way more than everybody else's. And so housing prices always have large outliers. So they're going to look more like this situation here. Okay, maybe I will draw one here. If you were to look at housing prices, it might look something like this. And then a couple of really expensive houses over here. So do you see what that does? It skews the data really far to the right. So your median, let's do median in green. Your median is going to be something like here. And your mean, which we'll do in blue, is going to be pulled way over here. Let's write those. Mean, median. So which of those two arrows do you think is a better indication for you, who's not really, really rich, just an average person, and you're thinking of buying a house? Which of those two arrows do you think is more useful to you as a number to represent a common house? You see, the median would be much more useful for you, wouldn't it? Okay, and so that's why you should do this. You should test me to see if I'm right. Look it up on the internet, and you will find everywhere that housing prices are talked about, it never says, or I shouldn't say never, you will almost never see mean housing price. Almost every single time you look it up, it will say median housing price. And it's the same thing with income. If you look up income and you want to say, oh, what's the normal income in that town? You look it up and you'll see it'll say median income. It won't say mean or average. It'll say median, because housing prices and income always have outliers in the right-hand side. And so they pull the mean really far to the right, and so that the mean is not really a useful measurement for things like housing prices and income. Okay? If there aren't outliers, then the mean is usually a good indication of the center. But if there are outliers, then the mean gets kind of ruined, and in that case we would use the median instead. Okay? All right, one last thing. I want to show you how to write a formula for the mean, and I want to remind you of something from chapter 1. Okay? I want to remind you of something. This is a reminder about population and sample. Okay? If you want to know about a population, you take a sample from the population and study it. Assuming the population is too big for you to study. Okay? So, you have population. That's the thing that you would like to know about, but it's too big to measure directly. So you take a sample and you measure the sample, and that'll give you an idea about the population. Okay? What if you're measuring the mean? So you would like to know the population mean. That's what you want to know. Okay? Well, that's too big. So let's say this. Let's say want to estimate the population mean. So you measure the sample mean. I want to remind you of these two words. This is called a parameter, and this is called a statistic. Remember, P with P, S with S. A population measurement is a parameter, and a sample measurement is a statistic. Okay, now here's the symbols that I want you to know. Okay, for population mean, we use the Greek letter mu. And for sample mean, we use an X with a line over it, and that's called X bar. Okay? Suppose you have a population with capital N individuals in it. Okay? Then let's write a formula for mu. So mu would be, let's just call it x1 plus x2 plus x3. And let's say that there's capital N many people in the population. So you would add up the measurements for all of those people, and you would divide that by the number of measurements, which would be capital N. Okay? But you don't really do that because capital N is so big and you can't measure everybody. So instead, you take a sample, and let's say that your sample has little n number of people. So you calculate the sample mean, which would be x1 plus x2 plus x3 plus and so on up to x little n, and you divide that by little n to get the mean. Okay, now there's a symbol that means adding up a bunch of stuff. You might have seen it before in a math class, and it is the capital Greek letter sigma, which stands for sum. And here's how you use it. For this thing here, you write sigma, meaning it's a sum. What are we adding up? So here, let's do this. Hold on. So we're adding up a bunch of x's, right? And so it's x1 up to xn. So you write it like this, xi, where I goes from 1 to capital N. And then we divide that by capital N. So I put times 1 over n. Okay? For the sample mean, it would look like this. The sum of the xi's, where I goes from 1 to little n, and then we divide that by little n. So those are formulas you're going to need to know. Okay? The population mean, where capital N is the number of people in the population, and this is the thing you would like to know, but you can't measure it directly because there's too many people. So instead you take a sample, and you can measure the sample mean. And little n stands for the number of people in the sample. This is important, okay? I want you to try to memorize this. Take a mental picture of it. It's very important. Okay, that's it for today.